Okay, so next let's have a look at the meninges. So in brief, what we could say is that the meninges are three layers of membranes that will envelope the brain and also the spinal cord. In mammals, like us humans, the three meninges are going to be the Dura Mater, which is highlighted now, the Arachnoid Mater, and then the last one, which actually very, very delicate, is called the Pia Mater. It doesn't highlight separately here because the Pia is intimately connected with or intimately adherent on the brain, but actually also posteriorly with the spinal cord. You cannot peel that off. The Dura and the arachnoid, however, you can peel off and remove from the rest of the brain and spinal cord. So if we were to have a look at potential spaces, well, if the Dura is the membrane, actually Dura Mater means tough mother, that is closest to the inside of the skull, well, above it there's not really a space, but there's a potential space, right? So if you have a bleed that is above the Dura, that would be an epidural bleed. That can happen, for instance, if you have a fracture of the temporal bone, so somewhere in this region here, because you have a very important artery, which you might have already heard of, the middle meningeal artery traveling just about here and then splits into anterior and posterior branches as it goes over the temporal bone. Well, if you have a fracture or a depressed fracture of the bone there, you can have a bleed of that artery that will likely cause an epidural aneurysm, which can be very, very dangerous. In addition to that, deep to the dura is your arachnoid mater. Well, once again, so there is a potential space between the dura and the arachnoid. Usually there is actually no real space there because deep to the arachnoid would be cerebrospinal fluid, and that pushes the arachnoid up tight against the dura mater, so you would actually not really have a space there. However, you could also have a bleed occurring, usually from a vein, that would then go in between the space between the dura and the arachnoid, and that would then be a subdural bleed. And then, last but not least, well, we've already talked about the pia mater, and the space between the pia and the arachnoid is the subarachnoid space. We will have cerebrospinal fluid coursing in here, and if we had a bleed into the subarachnoid space, that would most often result as an extravasation of arterial blood. For instance, the root factor for that could be a so-called saccular aneurysm, which might rupture. To give us a little bit more access, I have taken the liberty to cut away some more of the bone and other tissue structures that are in our way, because we want to have a look and be sure that our meninges that go around the brain actually continues with the ones that go around the spinal cord, and sure enough, they do. The spinal meninges are basically the same three membranes that the ones that are the ones that surround the brain. Yeah, you have the dura, and then you have the arachnoid, and then directly on the spinal cord you'd actually have the pia mater. Here it just says spinal cord. These here should be denticulate ligaments. They are actually a condensation of the pia mater. They're called denticulate ligaments because they actually do look a little bit like teeth, and their function is to anchor the spinal cord left and right on the sides to the arachnoid and the dura between the regions where the spinal nerve roots exit, so that it doesn't wobble back and forth too much. So to facilitate the explanation, I've actually added a little image here, and let me move it higher up. Here we go. So remember, we have these three meninges. We have the dura mater, then we have the arachnoid mater, and then we have the pia mater, which is directly adherent to the brain tissue. In addition to that, now imagine we have a coronal section, as you can see here, and the dura is not just one layer, it is actually a double layer, right? So where the dura peels away from the skull in the midline, it creates a fold or a wedge between the two cerebral hemispheres, and that is called the falx cerebri, or cerebral falx, all right? So you then have one layer that is like directly next to the bone, so it's called the periosteal layer, and the layer that peels away and ends up forming a double layer between the two parts of the brain, or between the two brain hemispheres, is then called the meningeal layer, right? So the periosteal layer and then the meningeal layer here, that in this case here forms the cerebral falx, and right there, this like channel that is formed here is actually called a venous sinus, a dural venous sinus. In this case, it will be the one that you can see here running sagittally. It is the superior sagittal sinus, actually the largest dural venous sinus. In addition to that, you can also see there are these little protrusions here, protrusions of the arachnoid from the subarachnoid space into the dural venous sinus. Those are called arachnoid granulations. And you might wonder what their function is. Well, their function is to help resorb the CSF, because it is continuously produced by the choroid plexi, and it helps to resorb the CSF into the venous circulation so that we don't have too much CSF pressure buildup in our brain. I'm going to close this now, or I'm going to minimize it. Okay, so now imagine that you would have your CSF circulating all the way around the brain without interruption. And so you have CSF circulating in the subarachnoid space all the way around the cerebrum, all the way around the cerebellum. Everything is basically bathed in CSF, and then at the foramen magnum, which is the big hole where the brainstem and then actually the spinal cord pokes through, you would have the CSF continuous, or actually also flowing around the spinal cord, all the way to the end. Okay, so let's put this all together. What are the meninges? Well, the meninges are 3 different layers of membranes. Their main function is to protect the central nervous system. That includes our brain and the spinal cord, of course. The 3 meninges are called the Dura Mater, the Arachnoid Mater, and the Pia Mater, as you can see here. The Dura Mater has 2 layers, a periosteal layer, which is directly adherent to the calvaria, or the skull from the inside, and the meningeal layer, which is the one that is lying directly on the brain. Between the meningeal layer of the dura and the brain, you have the arachnoid mater, and then directly sticking on the brain itself, for lack of better words, is the pia mater. Spaces, you'd have above the dura the epidural space, which would be a potential space here. Below the dura would be the subdural space, and below the arachnoid, which would be this space here where you usually have CSF in there, is the subarachnoid space. Another important thing to think about is, well, what could we use the CSF and our knowledge about the meninges for? Well, we can think about doing a spinal tap or a lumbar puncture, right? So you probably know that the spinal cord usually ends at about the L2 vertebral level. That means that after L1, maybe I can hide this and see if we can see what's below it. I'm going to hide this. Very nice. Look at this. So the dural sac extends all the way to the end at about S1 or S2. And if I hide all of the dural sac, we can see that we have a fine tapering of the pia, which is called the filum terminale down here. That actually continues all the way, anchors in the coccyx in the end. So if we were to insert a needle below this vertebral level, approximately L2, the spinal nerves will kind of move out of the way. We'll be able to aspirate some fluid. That's very important if you want to make sure that the CSF is clear. That means that you have no pathogens in there. If it's cloudy and you had a suspicion for bacterial meningitis, for instance, that could be an indicator. But of course, remember, do your microbiology. You need to plate your cultures and do some real science on this.